Welcome to another video. In this video, we want to talk about the relationship between half-life of a radioactive material and the decay constant. So this topic is radioactivity. So the question goes thus: prove that the relationship between the half-life, that is T half, and the decay constant lambda of a radioactive material is T half is equal to 0.693 over lambda. This T half means half-life. Before I play with the question, what is half-life? Half-life is the time taken for how the number of original atoms present to disintegrate or decay. Again, half-life is the time taken for how the original number of atoms present or radioactive material present to decay or disintegrate. So what we want to bring out here is the relationship between half-life and decay constants. It is pertinent and germane that the rate of disintegration minus the n dt is directly proportional to the number of atoms present. We should establish that minus the n dt is directly proportional to the number of atoms present. So what does that mean? That means the rate of decay is proportional to the number of atoms. Why am I putting minus here? I'm putting minus. This minus signifies that particular radioactive material is reducing with time. So that is the meaning of this negative. So it implies that the material is reducing with what? With time. And in science, anytime we mention rate, that means time is involved. Now, I will now transform this by removing this proportionality sign. Mathematically, I will do a bit of math here. If I remove this proportionality sign, I will introduce an equality sign and a constant. That constant is what is called the decay constant lambda. So this symbol is lambda. So that implies that minus the n dt is equal to, now removal of this give rise to the constant and n. So that is equal to lambda n. So at this juncture, I can move this negative sign to this side. If I multiply both sides by minus, I have the n dt is equal to minus lambda n. So I'm going to use what is called separable variable. This has given rise to a differential equation. We are having n is a function of t, while lambda is a constant. So this is a differential equation. I'm going to use separable variable. So I will move this dt. I will multiply both sides by dt. So if I do that, I have the n dt dot dt. This dot means multiplication is equal to minus lambda n dt. So I want n to be where the n is, and I want the t to be where lambda is. So that is what is meant by separable variable. So again, I will divide through by n. So the result here gives the n is equal to minus lambda n dt. So the next line of action is to divide through by n, so that I will separate the variables. So that is what is meant by separable variable. So if that is properly done, I will divide through by n. So n cancels n. So the n over n is equal to minus lambda dt. So since I'm having d of the function, I will introduce an integral sign in both sides. Let's introduce an integral sign. Then this lower and upper limit. The lower limit for this one will be n naught, while the upper limit will be what? N. So this n naught is the number of atoms originally present, then n is the atoms left after disintegration or decay. So here, that means the lower and upper limit at the right hand side will be when t is ranging from 0 to t. So here we go. So before I start solving this differential equation, we should bear in mind that whenever we are talking about definite integral is such an integral that is having both lower and upper limits. So the use of arbitrary constants is not allowed because the arbitrary constants will cancel out after evaluation. So that means I'm going to differentiate, I'm going to integrate this function. So this can also be written as integral upper limit of n, lower limit of n naught, 1 over n dn is equal to integral lower limit of 0, upper limit of t, minus. That minus, I'll bring it out of the integral, and that's lambda because they are both constant. So I will have minus lambda n dt. So the next procedure at this junction, recall. Let me just do that here. Recall that integral of 1 over x dx is equal to ln x. So this is a standard integral. So definitely this ln means log x to base e. So if the integral of 1 over x dx is ln x, which is the natural logarithm of x, that is the meaning of ln, natural logarithm, which can also be written as log x to the base of e. So similarly, 1 over n dn, the integral is also what? Ln n, just like that. So now I'm having upper limit of n, lower limit of n naught. So I will enclose this, then upper limit here, lower limit here. So what we normally do to upper and lower limit is that I'm going to substitute the upper limit, I'm going to substitute the lower limit and subtract my result. So what I do to the left, I will also do to the right. I integrate n, I integrate this one with respect to n. I'm going to integrate the right hand side with respect to t, where lambda is a constant. So it's equal to minus lambda. The integral of the t is t, because this is a constant function. Then that will give rise to t. Then upper limit of t, lower limit of 0. So I'm going to do the same thing. I will substitute the upper limit. I will have my result, substitute the lower limit, and subtract the two results. So this one can be written as log n to base e. That is the meaning of ln n, natural logarithm of n. Then into n naught. Then is equal to then minus lambda. Then when I substitute t for t, I have t. Then when I substitute 0 for t, I have 0. So at the end of the day, at this side, on the right hand side, I'm having minus lambda t. So now let's evaluate the one on the left. So when I substitute this, I should have log n base e, then minus, because I'm going to substitute this and subtract the result of substituting this. So minus log n naught to base e. So anywhere I see n, I replace it with n. That is the first part. Then anywhere I see n, I replace with n naught. So it's equal to minus lambda into t minus lambda t. So from the rule of logarithm again, recall that log x minus log y is equal to log x over y. That is second law of logarithm. So similarly, I can write this as log n over n naught base e. That is the way I can write this using this rule of logarithm. So n over n naught is equal to minus lambda t. Now again, I can also say that if I want to transform log to an exponential equation, again, if I'm having log x base y is equal to 2. So if I want to remove this logarithm, I will now say that this y here will now be a base of this, and this will be the power. So this implies that y, then this implies that x is equal to y squared. So similarly, I can remove this logarithm outrightly. If I remove this logarithm outrightly, I turn it to an exponential equation. I have n over n naught. So this will be a base to this, equal to exponential negative lambda t. So having written this, that means n over n not equal to exponential negative lambda t. So if I multiply through by n naught to make n the subject of the situation, so I have n over n naught multiplied by n naught is equal to n naught exponential negative lambda t. So this n naught crosses out this n naught. So n is equal to n naught exponential negative lambda t. So we should note that this n naught is the number of radioactive material originally present, while n is the number of radioactive materials left after decay or disintegration. Now, when T is equal to T half, then n is equal to half n naught. Now let me interpret this statement. This statement means when half of the original material has decayed, that is T half is the time taken for half the original materials to decay, then definitely half of the original materials will be left. So that means the amount left will be half the number of original material. So that is the reason I've written n equal to half n naught. That means half of the original material is left after half-life. Because half-life is the time taken for half the number of original atoms present to decay or disintegrate. So that means I'm going to replace this n with half n naught in this equation. So if that is properly done, now look at it. I will now say half n naught is equal to n naught exponential negative lambda t. So n naught crosses out n naught. So what does that mean? Half is equal to exponential negative lambda t. Now, mathematically and indicially, from the law of indices, if you are having x raised power minus a, it can also be written as 1 over x raised power a. So what I'm saying is that if we are having a negative index, the way to write a negative index is to say the reciprocal of the positive existence of this. So similarly, I can also rewrite this as half is equal to 1 over exponential lambda t, following this rule. So if I do the cross multiplication, I have exponential lambda t is equal to 2 times 1 is 2, 1 times this is exponential lambda t. So how do I remove this exponential? I will now say take log to base e of both sides. So take log to base e of both sides. So if that is properly done, I have log exponential lambda t to base e is equal to log 2 to base e. So from the rule of logarithm, this power moves to the back. So this guy here moves to the back. So we have lambda t log e to base e is equal to log 2 to base e. So from the rule of logarithm, when you're having the same log and the same base, so it's a neutral number, which is 1. So lambda t multiplied by 1 is equal to log 2 to base e. So lambda t times 1 is lambda t is equal to, now log 2 to base e, mathematically, log 2 to base e, that is ln 2. So the function of ln 2 is 0.693. That is the value of ln 2. So, and I said from Adam that we are talking about the time giving rise to half-life. That is the time taken for half the number of disintegration to do. So I'm going to replace this t with t half, which is the half-life. So I will have alpha t half is equal to 0.693. So if I now make our assertion was that we should make t half the subject of the formula, that is the relationship between t half and lambda. So if I make t half the subject of the situation here, I'll just divide both sides by lambda. So divided by lambda. So lambda crosses out lambda. T half is equal to 0.693 over lambda. Quite easily done. So that is the end of today's class. So don't forget to like my channel. Don't forget to comment Don't forget to view and don't forget to subscribe at Trigo Calculus. So life is always continuous, life is differentiable, life is integrable, but not Lebesgue measuring. It is a diet.